Assign the topics and I'll give some instructions in the afternoon. So please all of you join that class.
So,
Today afternoon we are having experiential learning session, no?
Sir.
So I'll take that up. So I'll join that. I'll wait for another 2 minutes. Let others also join. Yesterday I gave you one homework, one problem. Okay. So did you solve that? Anybody?
I did, sir.
Gayatri. This Pawan Pai.
Yes, sir.
Did you solve?
Yes, sir. I got 35.5 milligram.
How much?
35.5 milligram.
35.5 milligram of oxalic acid. Huh?
Yes, sir.
Okay, I'll solve it once again. So anybody else tried? Anybody else tried? Okay, we'll solve that same problem today. I'll just share the screen. I hope this board is visible to you. Can anybody unmute and respond?
Visible, sir.
yes, sir, it's
Okay.
visible.
Okay, I'll just write the problem here. In a COD experiment, this very important problem you should understand properly. In a COD experiment, 220 cm cube. Note down this problem: 20 cm cube of sewage sample. 20 cm cube of sewage sample made to react with all of you note down this 25 cm cube of K2Cr2O7. 25 cm cube of K2Cr2O7. Okay. After completion of the reaction, after completion of the reaction, unconsumed K2Cr2O7, unconsumed unconsumed K2Cr2O7, unconsumed K2Cr2O7 required 15 ml of or 15 cm cube of 0.05 normal FAS during titration. Same volume of K2Cr2O7, same volume of K2Cr2O7, same volume of K2Cr2O7 consumed 25 cm cube of 0.05 normal FAS in blank titration. If oxalic acid is the only impurity, calculate amount of oxalic acid. This is the problem. Hope you can hear me, right? One of you can unmute and respond.
Yes, sir.
Okay. So what is the problem? In a COD experiment, 25 cm cube of sewage water is made to react with 25 cm cube of potassium dichromate. After completion of the reaction, unconsumed potassium dichromate required 25 cm cube of 0.05 normal FAS during the titration. Same volume of potassium dichromate consumed 25 cm cube of 0.05 normal FAS in blank titration, and they have given one condition that the impurity present is only oxalic acid. Okay, then you have to find out the amount of oxalic acid present. Okay, so what are given here, you can write what are the given things. Back titration value is given. Back titrate value is how much?
15.
How much?
15 cm cube.
15 cm cube. Similarly, blank titrate value.
25 cm cube.
Blank titrate value is 25 cm cube. Blank titrate value is 25 cm cube. Normality of FAS is equal to how much? 0.05.
2.0.
Okay. So how much amount of FAS is consumed now? Amount of FAS consumed is equal to how much?
25 cm cube minus
25 minus
And
15. 10.
25 minus 15. So this is equal to 10 cm cube. 10 cm cube of potassium dichromate is consumed for the oxidation of this impurity present in this water sample. What is the impurity they have mentioned? Oxalic acid. Okay, only oxalic acid. That is in terms of FAS. Okay. Now you can write the equivalence. How will you write the equivalence? Can you tell me? 1000 cm cube of
1 normal FAS is
one
equal,
normal FAS
is
will
equal to
be
8 grams.
equivalent to how much?
8
8
gram of
gram
oxygen.
of
8 grams oxygen.
And this will be equivalent to, they told what is the impurity present? Oxalic acid. Okay, so this will be equivalent to, directly you can write the equivalence like this. So this will be equivalent to 1 gram equivalent of oxalic acid. 1 gram equivalent of oxalic acid. So this you can write now. 1 gram equivalent of oxygen will be equivalent to 1 gram of oxalic acid. Can you write like that? So the compounds or elements will react in terms of equivalents, right? So 1 gram equivalent of chlorine will be equivalent to 8 gram of oxygen. 8 gram of oxygen will be equivalent to 1 gram equivalent of oxalic acid. 1 gram equivalent of oxalic acid will be equal to 1 gram equivalent of FAS, right? So you can write the equivalence like that. But in your titration, how much potassium dichromate is FAS is consumed? How much FAS is consumed?
10 cm cube.
10
cm
cm.
10
Therefore,
cm.
10 cm cube of what is the normality given?
0.05.
0.05 normal.
0.05 normal FAS. So we are not going to calculate oxygen here because oxygen it is consumed for 1 gram equivalent of oxalic acid, right? So what is the gram equivalent of 1 gram equivalent of oxygen? Can you tell me? The molecular mass of oxalic acid is 90. Okay?
45, sir.
Molecular mass of oxalic acid is 90. Then what is the equivalent
45.
weight? Oxalic acid. What is oxalic acid? COH. COH is the oxalic acid, right?
Will it be
Yes.
90 by 2?
45
Are you following this or not?
grams,
Yes, sir. Will it be 90 by 2?
Can anybody unmute? Just respond whether it is
Yes, sir.
right or wrong.
45.
Okay. 45 because the oxalic acid molecular mass is 90, its equivalent mass is 45 because it is dibasic acid. 90 divided by 45. Okay. So therefore directly I can write 45 gram of oxalic acid. We are not going to calculate the amount of oxygen here. Directly they have given oxalic acid only present in the reaction mixture as the impurity. Okay. So directly equate to oxalic acid only, gram equivalent mass of oxalic acid. Okay. So now we can write like this. 1000 cm cube of oxygen, 10 cm cube of, 10 cm cube of 0.05 normal FAS is equivalent to, okay, how much? 45 into 10 into 0.05 divided by 1000. Divided by 1000. This is equal to, I'll convert directly into milligram. That's why I multiply by 1000. Okay, 1000. So this comes out to be 22.5 mg, 22.5 mg of oxalic acid. Have you understood this or not? So we, instead of expressing in terms of oxygen, we are directly expressing in terms of this oxalic acid because oxalic acid is the only impurity, organic impurity. Okay. So just consider that oxalic acid, equivalent mass of oxalic acid and write the equivalence, right? So this much 22.5 mg of oxalic acid you are getting in 10 cm cube of wastewater. But you have to express it to how much? 1000 cm cube. Therefore, 1000 cm cube, 10 cm cube, sorry, 20 cm cube. 20 cm cube contains 20 cm cube of wastewater contains how much? 22.5 mg of oxalic acid. 22.5 mg of oxalic acid. Therefore, you have to express it for how much? 1000 cm cube. 1000 cm cube of water sample contains how much? How we are going to calculate that?
22.5 by 20 into 1000.
For 20 cm cube, how much it is? 22.5. And how much for 1000? So this will be is equal to 1125 mg per dm cube of oxalic acid.
Yes, sir.
So here, instead of calculating in terms of oxygen, they mentioned oxalic acid is the only impurity. That is why we can directly equate it to the equivalent mass of oxygen. That's it. That is the technique. Hope it is understood to you. Clear or not? Okay, we'll consider one more problem. In a COD analysis, this also yesterday it is shown in a COD analysis. In a COD analysis, 25 ml of sewage sample consumed 8.3 ml of 0.001 molar K2Cr2O7. 0.001 molar K2Cr2O7. Calculate COD of water sample. Calculate COD of water sample. Okay. Here they have not done any back titration and blank titration. Are you following this or not? Directly they mentioned how much amount of potassium dichromate is consumed for the oxidation. Okay. Have you understood this problem or not? Can anybody unmute and respond?
Understood, sir.
Okay. So here what they have given, they have not given any back titration and blank titration. What is the role of back titration and blank titration? We just want to know how much amount of potassium dichromate is consumed, right? So, but here in this particular problem, directly they have given how much potassium dichromate is consumed. Okay. But one twist they have done here, instead of giving in terms of normality, they have given in terms of molarity. Okay. So that molarity you have to convert into normality. How you are going to do that? Come on. 1 molar K2Cr2O7.
Normality
Yeah.
into
Is equal to
1
6
molar
normal.
K2Cr2O7
Normality into
equivalent to
divided by
how
the
much?
6 normal.
6 normal K2Cr2O7. So if you understand this one, you can solve the problem. Okay. Therefore, 0.001 molar, 0.001 molar K2Cr2O7 will be equivalent to how much? 0.006 normal K2Cr2O7. Okay. So with this, you can calculate the COD. So now what step you are following? What is the step? Next step?
Sir, how did you get 1 molar K2Cr2O7 equal to
Pardon?
6 normal? How did you get 1 molar potassium dichromate equivalent to 6 normal?
You know the how to calculate this equivalent weight of potassium dichromate? Did you attend that first lab class?
Yes, sir.
Yeah, there we explained how to calculate the normality of equivalent mass of oxidizing agent, right? So this potassium dichromate is the oxidizing agent. In presence of acidic medium, it acts as oxidizing agent. Okay. So in that oxidation reaction, potassium dichromate reacts with sulfuric acid, it forms some salt, right? So in that salt, what happens? The oxidation state of potassium dichromate changes from +6 to +3.
Yes.
So what is the oxidation state of potassium dichromate in K2Cr2O7? It is +6. So in the product, it is changing to Cr2SO4, that is +3. For one oxidation, for the one chromium atom, +3 is a change in oxidation number. But there are two atoms are involved. That is why +6.
Yes,
Okay. So you are dividing the molecular mass by 6. then you are going to get the equivalent mass, right? So molecular mass, equivalent mass is equal to molecular mass divided by 6. Now you have to, it is given in terms of mole, right? That is why you have to, if you multiply that mole by 6, you are going to get normality.
Normality. Okay, sir.
Understood or not?
Yes, sir. Thank you, sir.
Okay. So you know the normality of, you convert this molarity of potassium dichromate into normality, and you know how much amount of potassium dichromate is consumed. Now it is very easy to calculate the COD. So what is the next step you are going to do? Come on, you have to tell.
1000 ml of 1 normal
Yeah, you have to write the equivalence. Equivalence you have to write.
equivalent to 8 gram of oxygen.
1000 cm cube of 1 normal FAS is equivalent to how much? 8 gram or 8000 mg of oxygen. 8000 mg. Instead of writing this gram, I am writing mg of oxygen. I am adding one more extra step. Okay. So with this you can calculate how much is consumed here. 8.3 ml. 8.3 cm cube of what is the normality? You calculated 0.006 normal FAS will be equivalent to how much then? How are you going to calculate that? 8.3 into 0.006 into how much? 8,000. 8,000 divided by 1000. So it is divided by 1000. I'm not able to write. Okay. So you will get the answer 0.3984 mg. So this 0.3984 mg is present in how much ml? 25 ml. 25 ml contains how much? 0.398 mg. Therefore, how much per 1000 ml? That you have to calculate. Okay. So can you calculate that? Cross multiplication.
Yes, sir.
Right? So it comes out to be 15.9. 15.9 mg per dm cube. 15.9 mg per dm cube. So the trick involved here is just to convert this molarity into normality. Okay. So we'll go to one or two BOD problems also. Yesterday we did not solve properly because of this internet issue. Have you understood these BOD problems? Alright, shall I solve one or two? So if you want me to solve, I'll solve. Otherwise, I'll go to the next portion.
Please solve, sir.
Okay.
Can you
Okay,
solve?
we'll solve. No problem. We'll solve. Okay. Note down this problem. $20 ml of 20 ml of sewage sample. Can you note down? Instead of I am writing, I just dictate. Are you able to note down?
Yes, sir.
Yes, sir.
Yeah. So I'll just dictate the problem. You note down. I'll solve the this thing problem then. So 20 cm cube of sewage sample was diluted to 600 cm cube. 600 cm cube. And equal volumes were filled in
Excuse me.
equal volumes were filled in 2 BOD bottles Full point.
So this question is done yesterday.
Yeah, yesterday done, but it is not solved properly. I'll just solve. I'll write the diagram and solve you. So only one problem I'll solve in detail. Okay. Have you understood this? Have you understood this problem or what? It is solved yesterday, but have you understood? If you understood, I'll go to the next type of problem.
So solve again.
Shall I
Yes,
solve again? Okay. So filled in 2 BOD bottles, full point. DO in one bottle, DO in one bottle, determined immediately 200 cm cube of solution, 200 cm cube of solution required 4.2 cm cube of N by 40 Na2S2O3, that is sodium thiosulfate. N by 40 sodium thiosulfate. Second sample was incubated for 5 days. Second sample was incubated for 5 days and DO determination, and in DO determination 200 ml solution or 200 cm cube, right? 200 cm cube solution was required 2.2 cm cube of N by 40 sodium thiosulfate. Calculate BOD. Okay, I'll read out once again. Note it carefully. 20 cm cube of sewage water sample was diluted to 100 cm cube and equal volumes were filled in 2 BOD
100 or
bottles.
600 cm cube?
600 cm cube and equal volumes were filled in 2 BOD bottles. Full point. DO in one bottle determined immediately 200 cm cube of solution required 4.2 cm cube of N by 40 sodium thiosulfate, that is Na2S2O3. Full point. Second sample was incubated for 5 days and in DO determination 200 ml of solution was required 2.2 cm cube of N by 40 sodium thiosulfate. Calculate BOD. Okay, so what is given here? They have taken 20 cm cube of water sample whose BOD is to be determined, and it is diluted to how much? 600 cm cube by using what they will use for dilution? Come on, BOD you studied, no? What they will use for dilution? You have to respond.
Dilution water.
Dilution water, good. Respond immediately, man. You can save my time. Okay. So dilution water they used. So how much ml of dilution water they used to make it up to 600 cm cube? Man, already 20 cm cube is there. How much they have to add? Dilution water they have to add?
580.
580 ml. Okay. In some problems they will give like this. So they will not say that it is diluted up to 600 cm cube. Just to confuse you, 20 cm cube of wastewater sample was added with 580 cm cube of dilution water. Then what is the total volume you should remember? You should calculate. You should take 600 cm cube, right? So they will twist like this. You just remember. But you need initial volume and final volume. What is the initial volume here? 20 cm cube. And final volume is 600 cm cube. To calculate that dilution factor, you need this one. Okay. So sometimes what they will do, they will not give like this 20 cm cube is related to 600 cm cube. Okay. So instead of that, they will say that 20 cm cube of wastewater sample is added with 580 ml of 580 cm cube of dilution water. Then they will write, they are going to give that whole problem. It is divided into two equal parts. First part is, for first part, DO is determined immediately. For second part, DO is determined after 5 days, and all the data they will give. Okay, don't get confused here. So both are same. 20 cm cube is added with 580 ml of water, dilution water is also same, or they can give like this also. 20 cm cube is diluted to 600 cm cube instead of mentioning that 580 cm cube. So many students will get confused here. Have you understood this point?
Understood.
Okay. Now this 600 cm cube water sample is divided into two parts. So just go on reading the problem. So this is first day and this is fifth day. Okay. So first day, when they determine the DO, how much sodium thiosulfate is consumed? How much?
4.2
4.2
centimeter
cm
cube
cube.
of N by 40.
So 4.2 cm cube is consumed. How much? What is the normality of sodium thiosulfate? N by 40. So N by 40, if you convert it into a decimal, how much it will be? 0.025, right? 0.025 normal.
Yes, sir.
So after fifth day, how much it consumed? It is, how much it consumed after
Point-
fifth day?
2.2 centimeter cube of N by 40.
2.2 cm cube of same sodium thiosulfate, that is 0.025 normal. So now you have to calculate BOD. Three things they have given. How much sodium thiosulfate is consumed on first day, how much sodium thiosulfate is consumed on fifth day, and what is the dilution factor you can calculate. What is the initial volume and what is the final volume. And in both the cases, they have taken 200 cm cube for titration. 200 cm cube for titration. Okay. So the principle involved behind this calculation is this Winkler cytometric method. Same calculation you have to use. Okay. So to calculate the DO on first day, DO on first day. To calculate DO on first day. So what you have to do, you just use the N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. So this N2 V2 we can consider it as sodium thiosulfate, N2 Na2S2O3, sodium thiosulfate, and N1 V1 for water sample. And N1 V1 for water sample. Okay, first day, what is the normality of water sample you have to calculate? That is N1 you have to calculate. And volume of water taken is how much? How much?
200.
For titration.
100 cm cube.
200 is equal to, so N2 is how much? Normality of sodium thiosulfate is how much?
0.025.
0.025 into, what is the volume?
4.3 centimeter
4.2.
cube.
How
4.2.
much? 4.2. First day. First day it is
4.3.
4.2 or 3?
Oh, sorry, 2, sir.
4.2. Okay. Therefore, N1 you calculate. N1 is equal to 0.025 into 4.2 divided by how much? 200. So
200.
it comes out to be 5.25 into 10 to the power of minus 4. Okay. Into 10 to the power of minus 4. N1 is this much. So how we are going to calculate the normality? The normality of oxygen is this much. Okay, N is nothing but what? This N1 is nothing but what? Normality of oxygen. So amount of DO, how you are going to calculate? If you multiply normality by its gram equivalent mass, you are going to get the amount of substance. Okay, so amount of DO or amount of dissolved oxygen in sample is equal to normality into gram equivalent mass of oxygen. Gram equivalent mass of oxygen. What is the normality calculated here? It is 5.25 into 10 to the power of minus 4 into 8 gram. That will be converted into milligram. So it is 1000. So this will be equal to 4.2 mg per dm cube. So this calculation you should remember always in volumetric analysis. So amount of the, if you know the normality, for example, if you know the normality of HCl, so if you want to find out the normality of HCl present in 1000 cm cube, what you have to do is you just multiply with the normality by its gram equivalent mass, right? So here the same thing, we know the normality of oxygen, right? That is 5.25 into 10 to the power of minus 5. I want to calculate how much amount of oxygen is present in 1 dm cube of water sample, right? For that, what I have to do, I have to multiply this normality into gram equivalent mass of oxygen. So this is D1. So D1 is equal to how much then? D1 is equal to 4.2 mg per dm cube. 4.2 mg per dm cube. Okay. So this is D1. Similarly, you calculate D2. Similarly, you calculate D2. How you are going to do that? Again, N1V1 of sample is equal to N2V2 of Na2S2O3. Okay. So here again, N1 you have to calculate. V1 you know how much it is. How much water sample you have taken?
200 centimeter cube.
200.
cm cube. So this is equal to N2 is how much? Normality of sodium thiosulfate, again it remains constant, that is 0.025 into how much sodium thiosulfate is consumed, it is
2.2 cm cube.
how much? 2.2. Therefore, this normality is equal to 0.025 into 2.2 divided by 200, and this comes out to be
2.75 into 10 to the power minus 4.
2.75 into 10 to the power of minus 4. Okay, so if you want to calculate the amount of this oxygen, amount of oxygen present in 1000 cm cube, what you have to do? Therefore, amount of DO in 1000 cm cube, you can say 1000 cm cube of water sample is equal to how much? What you have to do? Multiply this normality by what?
8 grams.
8 gram. Okay, so that is gram equivalent mass of oxygen, right? So you have to multiply this by 2.75 into 10 to the power of minus 4. I will directly convert it into milligram, 1000. So this comes out to be 22.2 mg. 22.2 mg per dm cube. So now you know D1 and D2. D2 is equal to 22.2
That's only 22.
mg per dm cube.
Sir, it's just
Any
22.
doubt you are having? Pardon?
Sir, it's just 22, right?
Yeah, 22.2 mg per dm cube. You just calculate it. Okay. Now, how will you calculate BOD? What is the BOD formula? BOD is equal to, come on. How will you calculate BOD? What is
D1
BOD
minus
formula?
D2.
D
Huh?
plus D2.
Come on.
D1 minus D2.
D1 minus D2 into
Volume
dilution
after
factor. What is
dilution.
the dilution
Volume.
factor? Volume after dilution
by volume before dilution.
Volume before
Before
dilution.
dilution.
Volume after dilution. Volume before dilution. It is 4.2 minus 2.2 into 600 divided by 20. And this comes out to be 600 mg per dm cube. 600 mg per dm cube. This is the BOD. Okay. So BOD of sample is 600 mg per dm cube. So this is one type of formula. Straightforward problem it is. Okay. There is one more type. Directly they will give. Just note down this problem. This is also solved, but I want to just write it and solve. Note down this. Calculate the BOD of effluent. Calculate the BOD of effluent sample containing. Calculate the BOD of effluent sample containing 8.2 mg per dm cube. 8.2 mg per dm cube of organic matter. 8.2 mg per dm cube of organic matter represented by the formula CH2O. CH2O. This is the formula. Okay. This is very straightforward and simple problem. They have given the molecular formula of the biodegradable impurity, that is CH2O. This is an organic compound. Okay. Whatever it may be, this is an organic compound because it contains only carbon and hydrogen. Of course, oxygen will be there, but it is organic compound. Right. So when it is subjected for BOD estimation, it will undergo oxidation. Right. So in presence of oxygen, it will undergo oxidation. It will undergo oxidation to what? What are the products? Oxidation product. In presence of oxygen,
CO2 and
it will
H2O.
undergo oxidation to carbon dioxide and water. Okay. The oxidation products of carbon is carbon dioxide, and that of water, hydrogen is water. Are you following this or not? And if sometimes they will give the formula wherein you need to balance the reaction. Okay, but here it is balanced already because there is only one carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. It is balanced. Now, what is the molecular weight of this organic compound? What is the molecular weight of this
30.
organic compound?
30.
It is 30. This is 30. And what is the molecular formula of this oxygen? 32.
32.
That means if you take 30 gram of this organic compound, if you want to oxidize it, it consumes how much gram of oxygen? 32 gram of oxygen. Are you following this or not? 1 mole of this organic compound requires 1 mole of oxygen, or 1 gram equivalent of this one requires 1 gram equivalent of oxygen. Right? Very, very simple. So you can write the equivalence like this. 30 gram of compound needs 32 gram of oxygen for oxidation. Okay. Therefore, how much you have to calculate? Therefore, 8.2 gram needs how much? Sorry, 8.2 mg needs how much? Okay. So how we are going to calculate that one? Come on. Just cross
8.74
multiplication.
8.74.
8.74. How we calculated that one? 30, for 30 it is 32, and for 8.2, how much you have to calculate? So this comes out to be 8.74 mg. Already it is given for per dm cube only. In the problem only it is given per dm cube, right? So this is also per dm cube only you are going to get. So this kind of simple problem also it is asked. So if this kind of organic compounds are given, you just write the oxidation reaction for that. And if the reaction is not balanced, you balance the chemical reaction. Okay. So after balancing it, you calculate the molecular formula of the compound and molecular formula of that how much oxygen is required, how much equivalent of oxygen is required, right? Then you write the equivalence. Just by cross multiplication, you are going to get the answer. Okay. Any doubt here?
No, sir.
Or everything is doubtful?
No.
Understood, sir.
Understood, right? Okay. So this kind of simple problems are asked in your exam, right? So in COD and BOD, this kind of simple problems will be asked. So problems on COD, this hardness of water is solved, right? It is solved or not? Hardness problems.
Solved.
Yes, sir.
All
Solved.
It is solved, right? Those are very simple problems. You can solve those things. Okay. And it is there in our notes also. The problems are there in our notes also. You just go through those things, right? So notes I uploaded in your Google Classroom, and it is available in Quick Learn also. Okay. So have you gone through? You gone through the notes or what?
gone through.
Okay. Now what I'll do, I'll just give the introduction about. Can you see this PPT?
We can see.
You able to see this?
Yes,
Sir, we can see.
Yes, sir.
Okay. I'll just give introduction about this membrane technology. Okay. So far what we did, we studied what are the possible impurities present in water, right? So can you tell me what are the possible impurities? Come on. Can anybody unmute and respond now? You don't know what are the possible impurities present in water samples?
Lead.
Yeah, salts will be there.
Lead.
Yeah, heavy metals will be there. Okay. Then what else? Organic impurities will be there. Inorganic impurities will be there.
Industrial waste.
Okay. And industrial waste. Industrial waste will contain what? This organic and inorganic impurities, right? And also, due to presence of some salts like calcium and magnesium salts, it will lead to the hardness of water. Okay. And some other inorganic salts are also, dissolved inorganic salts are also will be there. And the impurity due to all these dissolved inorganic salt, it is called as TDS, total dissolved salts. Have you heard this word? TDS? Total dissolved salts. Total amount of salts present in water, total dissolved salts. Okay. So you might have seen the service person of your Kent purifier. He will bring one meter, right? He will bring one sensor, and he will measure. He will take your water sample and measure some parameter, right? Do you know what is that parameter? Some parameter he will measure, 35, 36 he will tell. Do you know what is that? So it is nothing but TDS, total dissolved salts. Okay. So it is total dissolved salts he is going to measure. So these are also going to be impurities in your water sample. Now, for some specific application, you need to purify the water. For example, if you want to go for drinking water, what all material you have to remove from that? What are impurities you have to remove? If any organic impurities are there, will you drink that?
No, sir.
No, sir.
No, you have to remove that, right? You have to purify. And if too much total dissolved salt is there, then what you have to do? You have to reduce the dissolved salt, right? Means you have to purify that. You have to filter it. Okay. If pathogenic microbials are there, right? You have to remove those things also. Then only it is fit for drinking purpose. Okay, so that kind of water is called as what? Water which is fit for drinking purpose is called as
Potable water.
potable water. Okay, so these are all characteristics of a potable water. For example, if any smelling reagents are there, smelling impurities are there, you have to remove those things also. Then only it is fit for drinking purpose or domestic applications. For example, if you want to use this water for some industrial applications, for example, in sugar industry, paper industry, then if too much hardness is there, the sugar will not crystallize out from that sugarcane solution. You will not get the crystals. You have to reduce its hardness. And in paper industry, if it is too much hard water, so you are not going to get a proper quality, good quality paper, right? So you have to reduce the hardness of water, and also some total dissolved salts you have to remove, right? For that, again, you have to go for one kind of purification, right? So different applications need different kind of purification, different specifications of water, right? So for such kind of purifications, we are using some polymeric membranes. Okay, we are using some polymeric membranes, and purification of this water by using this kind of polymeric membranes, it utilizes this membrane technology that we are going to study now. Okay. Okay, see here, for drinking purpose, we need to go for a kind of water purification, right? And also for process water production, if you are going to use this in industrial processes, right? Then also you have to go for another kind of purification, because the specification is different. The specification of drinking water is different. Specification of water which you are going to use in industries, that is different. And you have to convert this brackish water, right? Brackish water into drinking water, that is potable water. Brackish water means what? It is a sea water which contains highest percentage of water, dissolved salts, highest percentage of dissolved salts, right? So that will be done by desalination. This desalination is nothing but removal of the salts from water, right? So it is called as desalination. Saline water means what? Simple. What it contains? Saline water.
Salt.
Salts.
So it contains salts, right? It contains some minerals. Minerals are salts, nothing but salt. So desalination means removal of those kind of salts. Okay. So you know that our this industry, this seawater contains many salts. So you have to remove that. Then you can use it for other purposes. That process is called as desalination. Okay. And municipal water wastewater treatment. This municipal wastewater contains what? Lot of organic load, inorganic load, right? Kitchen waste, everything it contains. It has to be purified, and then it should be discharged into rivers and other lakes. Otherwise, it creates water pollution. So all these things involves some kind of purification, and all these purification methods involves membrane. In water technology, purification is called as membrane technology. Okay, so this is the brief introduction for this. I'll stop it here, and I'll continue to next class. Right? What are the different types of membrane technologies are there? What are the different types of membranes, and how this drinking water is purified? Okay, and what are the advantages, disadvantages? All those things we'll consider in next class. Today, afternoon session, I'm going to engage. Okay, afternoon session, I'll engage, and I'll give instructions about this, how to proceed for this EL. So all of you are you have made the team, right? So only one person is left. Who is that? I don't know. Okay, so in last team 9, only 2 people are there. It should be 3. one person has not nominated there. So he has to enter his name. Otherwise, it's very difficult. Okay. We are going to value this EL component for 60 marks. If you have seen your syllabus and all, you will come to know. Right. So you have to take it seriously. So all these instructions I am going to give in afternoon's class. Right.
Okay, sir. Okay, sir.
Any doubts you are having?
No,
Sir.
You don't have any doubts?
no, sir.